Hello and welcome to our lesson on points on a coordinate plane. So what we're looking at specifically is technically referred to the Cartesian coordinate plane. That's a fancy word for what you would probably call a graph, okay? So the Cartesian coordinate plane, or just the coordinate plane, is a two-dimensional area that is created by the intersection of two perpendicular lines, and we call those perpendicular lines the x and y axis. So the x-axis and the y-axis are two perpendicular lines. Perpendicular just means they create 90-degree angles. They intersect at a perfect T. So we would call, we call this a vertical line, and then we have this horizontal line. They are perpendicular, and one of them is referred to as the y-axis, that is the vertical one, and one is referred to as the x-axis, that is the horizontal one. And again, those are what intersect to create this coordinate plane, okay? So the axes themselves, they break the plane into four regions, which we call quadrants. So they break it into four quadrants or regions, and we label those using Roman numerals. And so we have quadrant 1, and then quadrant 2, and then quadrant 3, and then quadrant 4. So we start in the top right, and then we work our way counterclockwise as we label, okay? So that's 1, 2, 3, and 4. And then the point of intersection for our axes we call the origin. So the origin, right smack in the middle, is where our two axes intersect. So that's our origin. And let me just coordinate our highlighting here. And then x and y axis. Okay, the y axis, again, the y axis is the vertical axis. And it represents a number line, and you can see that it's labeled with numbers there, but it represents a number line where it goes down infinitely toward negative infinity, so it'll go down forever, and it goes up infinitely toward positive infinity, so it goes up forever. But it's just a number line where 0 is right smack in the middle, and then it goes up and down forever. And then the horizontal axis, again, that is the x-axis. And that horizontal axis, again, it's just a number line, but instead of going infinitely up and down, it goes infinitely left and right. And infinitely to the left would be toward negative infinity, and infinitely to the right would be toward positive infinity. Okay, so this is the Cartesian coordinate plane, or just the coordinate plane. And again, we could just call it a graph, but created by the x and y axis. Now, the whole purpose of the coordinate plane is so that we can plot points, and usually, today is going to be pretty generic. We're literally just going to be plotting points, but ultimately the goal is to plot points that come from particular functions so that we can kind of see the behavior of functions, okay? But before we get that far, when we're plotting points or coordinates, so coordinates are just points, and I forgot to put it here, but they're also sometimes called ordered pairs. So a point or a coordinate or an ordered pair, those are all synonymous. But coordinates or points are plotted on this coordinate plane using the origin as the point of reference, or like the starting point. And our points or coordinates or ordered pairs are written in this form, where we have an x value and then we have a y value. And the x value that is in that coordinate, so the first number that we see in our ordered pair, it indicates how far to the left or right that our coordinate should be moving from the origin. And so if you have a positive x value, that means you're going to start at the origin and go to the right. If you have a negative x value, that's going to indicate for you to go to the left, which should make sense. So think about here's 0, right? That color's not really showing up. Here's 0 at our origin. That's our starting point. If we have an x value that's positive, we're going to go toward the positive x's, which is to the right. If we have an x value that's negative, we're going to go toward the negative x values, which is to the left. Okay, and then the same thing happens with the y value. So the y value, or the y coordinate, or that second number in our ordered pair, is going to tell us how far up or down we're going to move from the origin. So if we have a positive y value, we would go up toward those positive y values. And if we have a negative y value, we're going to go down towards those negative y values. Okay, so when we're looking at an ordered pair, it is literally giving us a direction where we start at the origin, and then from there we either go left or right, or we go up or down, or maybe we don't move at all, just depends on what the coordinate gives us. Okay? And just so that you are, or we are clear, if we have positive x values and positive y values, any point that has a positive x and a positive y will land in quadrant 1. If we have, oof, I gotta sneeze, it's coming. Sorry. If we have negative x values and positive y values, so we get a negative x and a positive y, anything with a negative x and a positive y will have to land in quadrant 2. If we have a negative x value and a negative y value, if everything's negative, negative x, negative y, then we have to land in quadrant 3. And if we, oops, went too far, have a positive x value and a negative y value, positive x, negative y, we're going to land in quadrant 4. And sometimes we don't land in the quadrants at all. If we only move up, or we only move down, or we only move left, or we only move right, one of our coordinates is going to be a 0, then we could end up on one of the axes. And so if we landed on the positive part of the x-axis, then we would say our coordinate is on the positive x-axis. If we landed here on the negative x-axis, we would say our coordinate landed on the negative x-axis, and the same would be true for the y. Okay, so let's just practice plotting some points. Let's see. So for example, if I wanted to plot the ordered pair, or the coordinate 4, 5, starting at the origin, this positive x value tells me to go to the right 4, and this positive y value means tells me to go up 5. So from the origin, if I went right 4 and up 5, I would land at 4, 5. So from the origin, if I went right 1, 2, 3, 4, and then up from there 1, 2, 3, 4, 5. That is where that point is located. So the coordinate 4, 5, or A, would be right at that spot. Okay? So this is really tiny. This lands, if we go from the origin right 4 and up 5, then we land in quadrant 1. Okay, let's try that again. So next, we're looking at negative 3, 1. So a negative 3 for my, let me do this. This is our x and this is our y. Again, this is our x value, this is our y value. So negative 3 on the x would mean to go to the left 3, and positive 1 on the y tells me to go up 1. So from the origin, if I go to the left 3, 1, 2, 3, and then up 1, I'm going to land right here. So that is the location of point B, and that is in quadrant 2. Okay, next one. Let's see if I can rotate my colors here. Again, this is our x, this is our y. So a negative x tells me to go to the left 6, and then negative y is going to tell me to go down 2. And if I go from the origin to the left, 1, 2, 3, 4, 5, 6, and then from there down 2, 1, 2, then I land here, so that would be the coordinate for C, and that one is in quadrant, we can see it, quadrant 3. That is in quadrant 3. And you can probably deduce from the pattern where the next one's going to land, but again, this is an x and this is a y. So the positive x is telling me to go to the right, and since it's a 5, we'll go right 5. And then the negative y tells me to go down. Since it's a negative 8, we're going to go down 8. So from the origin, if I went to the right 5, 1, 2, 3, 4, 5, and down, 1, 2, 3, 4, 5, 6, 7, 8, I'm going to land here. And so that is the coordinate for point D, and that is located in quadrant 4. Quadrant 4. Okay? And now we have some that are going to be on the axes. So 0, 6. Remember, this is an x, this is a y. 0 on the x means I'm not going left or right at all. So that's no left or right movement at all. But the 6 on the y is telling me to go up 6. So from the origin, I'm only moving up 6. I'm not going left or right at all. So from the origin, if I just went up 6, then that is the location for point E. And that we would say is on the positive part of the y-axis. So that is on the positive y-axis. Okay? And then let's see here again. This is an x and this is a y. So that negative x tells me to go to the left. And it's a negative 4, so that's left 4. But this time I have a 0 for the y. So not moving up or down at all. I'm just going to go left 4. So from the origin, if I go left 4, I land right there. So that is the coordinate. That is the location for coordinate f, and that is on the negative part of the x-axis. So that is on the negative part of the x-axis. All right. What do we have next here? Running out of colors. Let's go to a custom. How about orange? Okay, so 2, 0. Again, this is an x, this is a y. So 2 in the x spot there, positive 2 means to go to the right. And again, it's 2, so right 2. 0 for the y, so I'm not moving up or down. I'm just going to the right 2. So from the origin, if I go to the right 2, I land here. And so that is a location for the point G, for coordinate G, and that is on the positive part of the x-axis. That is on the positive part of the x-axis. And then I've got one more, which I need another color. Let's try that one. So for this last one, again, here's our x, here's our y. No movement on the x, not going to go left, right, just a -7 for the y. So that's going to be down 7. So from the origin, if I move down 7, I land here, and that's the location for point H. And again, that is on the negative part of the y-axis. So the negative y-axis is the location there. Okay? So hopefully that makes sense. Hopefully this is something we've seen before. This is a good review. Now let me just mix in a little bit of geometry to try to make this somewhat interesting. For example, it says rectangle ABCD has vertices at A, B, C, and D we have to find. So vertices are the corners of the rectangle. So let me go back to my presets here. The vertices are just the corners. So one of the corners is at -3, 2. So if I went to the left 3 and up 2, left 3 up 2, that is where point A is located. That's where one corner of my rectangle is located. And then B is at 4, 2. That's to the right 4 and up 2. From the origin, right 4 up 2 puts me here. So that's point B. That's another corner of my rectangle. And then C is at -3, -1. That's to the left 3 and down 1. So from the origin, if I went left 3 and down 1, I would land here. So that's the coordinate for C. And the question is, if this is a rectangle, where is a vertex D? Where does our last point have to land? Well, let's just connect these. Okay, so I have right now that side of the rectangle. I've got this side of the rectangle. If I was to finish this rectangle, this is the only way I could finish the rectangle, right? That tells me exactly where my last point has to be, where my last vertex has to be. So D is going to be here. So D is located at, let's see, from the origin, if I go to the 1, 2, 3, 4. If I go to the right 4 and then down 1, so right, oops, I do not want to use that color. That's bad. That is to the right 4 and then down 1. Then my coordinate would be at +4 and -1. Alrighty, that wasn't too bad. Sometimes we hear geometry and like, ooh, haven't seen that in forever. but that's pretty manageable, I hope. All right, last one. It says find the area of triangle PQR with vertices at the origin 0, 10, and 12, 0. So area of a triangle. Area of a triangle is found by multiplying 1/2 times the base of the triangle times the height of the triangle. So let's draw this out and see if we can't find the length of the base and the height in order to use this formula. So the origin, we know where that's at. The origin is 0, 0. Okay, so there's that point. And then 0, 10. That means we're only going to be going up 10. So from the origin up 10 is there. And then 12, 0 means we're just going to be going right 12. That's there. So this triangle, if we connect these points, looks like this. You like my little cheat tool, right? So how long are the base and the height of the triangle? So the base and the height of the triangle are the ones that, like the x and y axis, they make a 90-degree angle. They make that perfect T when they cross. So this is going to represent my base and my height, these two lengths here. Well, I can see that to go from 0 to 10 or up 10 units, that makes this length 10. And to go from 0 to 12 or right 12 units, that makes this length 12. And so to find my area, I'm going to use my base and my height as 10 and 12. So my area is going to equal 1/2 times 10 times 12. So in this case, half times 10 times 12. You can do the 10 times 12 first and then multiply a half, or take the half of 10 and then multiply by 12. Remember, the order that we multiply doesn't matter. So if you want to multiply here first to make 5 and then multiply by 12, you're going to end up with 60. And we don't have any units here. Technically, it'd be square units for area. So units squared, but if this was a problem in your Canvas assignment, it's not going to want you to input units anyway, so just 60 would be fine. Although I think the one that I put in your practice assignment calls for perimeter. If we had to find the perimeter, we would have to know the length of all three sides, and we would add those together. That would require some extra work if it was a triangle. The one that's in your practice, I believe, is a rectangle. So don't forget, if you want to find the perimeter of your figure, whatever your figure is, you're adding up all three of the side lengths. Okay, but for this one, area is going to be, excuse me, 60 units. All right, so hopefully you have enough to plot points and know the location of coordinates on a Cartesian coordinate plane. But as always, if you need some extra help, then just reach out. All right, guys, take care.